In October 2011, the world passed the 7 billion landmark. So today there are just over 7.2 billion citizens living in the world. And what I'm going to try to do over the next 30 minutes or so is to give you a flavour of how the world has been transformed over the last 50 years, what lies behind population change, and what are the potential implications of it going forward over the next 50 years. It's a really exciting time to study demography. This graph shows you world population growth over the last millennium, and you can see the scale at the bottom is in different units. So for the first 100 million years or so of human history, we bumped along at around 100,000 people. And then gradually the population started to rise, and you can see that in the middle of the last millennium, with the Black Plague, the population had grown to around 300 million or so. Then we had the Black Plague and had a dip down. And then something dramatic happened at the beginning of the 19th century. And population has grown over the last 300 years from less than 1 billion to the 7 billion it is today, and we were predicted to even out at around 10 billion by the end of this century. The first billion took the whole of human history up until about 1800 to reach the first billion. We then took 130 years to reach the second billion in the world by 1930. Then we started to get a little bit more precise in our timings. And according to the United Nations Population Division, we hit the third billion on the 20th of October 1959. Of course, we don't really know if it was the 20th of October, but those are the estimates. Then the pace of change really speeded up, and it only took 15 years for us to hit the 4th billion, then another 12 years to hit the 5th billion, another 12 years to hit the 6th billion, and now things are starting to slow a little bit, and it took 13 years to hit our 7th billionth citizen on the 31st of October in 2011. Where are these people living? Well, I think most of you will know that they're concentrated in the developing world, and China and India both have populations of over 1 billion. However, although the populations are now concentrated largely in Asia, the growth rate of the current population is mainly in Africa, and 7 of the top 10 growth rates today are in African countries. Whereas in the developed world, it's really migration that is the key factor driving population change. This graph shows you how the world has changed over the last 60 years. And you can see the concentration of growth in Asia, which is the light blue area. However, if you look at the slope of the lines, that gives you an indication of the speed of change. And actually the population of the African subcontinent has more than quadrupled over the period of time. In fact, it's 4.5 times as large today as it was in 1950. Whereas in Asia, it's 3.5 times as large, and the same factor roughly applies in Latin America. Whereas you can see that the population of Europe, which is the yellow lines part of the graph, has actually been primarily stable over this period of time. So let's think a little bit more about what drives population change. Populations are really just a function of the births and the deaths and the migration. So the population at time 2 will be equal to the population at time 1 plus the births minus the deaths. That's at the global level. But of course, if we think regionally or about countries, we also then have to factor in people moving in and people moving out. So it's births minus deaths plus in-migrants minus out-migrants. And this graph shows you a theoretical construct that we use within demography to understand population change. And it shows you in a very stylized way something that we call the demographic transition. So at stage 1 of the demographic transition, we live in a world with high and stable birth rates and high and fluctuating death rates. Death rates fluctuating from year to year due to epidemics, famines, wars, etc. But basically, the population is in equilibrium with similar numbers of births to deaths. Then we enter into stage 2 of the demographic transition, where the death rate starts to fall, but the birth rate remains roughly the same. And it's this difference between the number of people who are being born and entering the population and the number of people who are dying and therefore leaving the population that causes populations to grow. Over a period of time, the birth rate then follows the decline in the death rate. And by stage 4, again, we end up back at equilibrium, but now we have low and stable death rates and low and fluctuating birth rates. And it's really this, the pace of change, how quickly the death rate falls and how quickly the birth rate then falls to follow it, that drives population change. So if we think in Western Europe, the first country really to enter the demographic transition was France, where death rates started to fall towards the end of the 18th century. Birth rates then started to fall as the countries entered into the Industrial Revolution. And today, France has low and stable birth and death rates. But this transition took nearly 200 years. Whereas in many of the countries of the developing world, they've actually undergone the demographic transition in the post-Second World War period, with really quite dramatic falls in death rates, followed by dramatic falls in birth rates. And we'll have a look at those in a moment. Just to show you that this isn't a completely artificial construct, this shows you actually real data from Sweden over an extended period of time, over 3 centuries. And Sweden's a fantastic country to draw on because they have excellent data going all the way back into history. And you can see roughly the birth and death rates do follow the pattern of the demographic transition. So today, as we stand in a world of 7 billion, and we look back over the last 60 years, the world has been transformed, and it's been transformed in a number of different ways. Firstly, we live in a healthier world. And this graph shows you trends in life expectancy over the last 60 years, broken down by different regions of the world. And you can see that in all parts of the world, there's been quite dramatic improvements in life expectancy. Life expectancy is actually a hypothetical construct. It shows you the number of years a person would be able to expect to live throughout their lives if they face the same risk of death that currently prevails at each year of their life. And you can see that in the world, in 1950, the average life expectancy was 48. Today, it's 68. So that's a 20-year improvement in life expectancy in around about 60 years. So 20 years in 60 years is actually 2 years in 6, or 1 in 3, or 3 months a year, or 2.5 days a week, or actually 8 hours a day. So if you start to think about that, then that's just amazing, the improvements in life expectancy. Of course, that's not a real improvement of 8 hours a day. That's how the change has played out. But life expectancy has been improving at a rate that I think many of us as demographers haven't foreseen. So we live in a healthier world. And just to give you an idea of how that plays out across different countries, these stacked bar charts show you the proportion of the population in the world which was living in countries with different life expectancies. And in 1950, 2/3 of the world lived in countries where life expectancy was less than 50. Today, 2/3 of the world live in countries where life expectancy is over 70. And many of us can expect to live to 80 or 90 or beyond. So as well as a healthier world, what we're starting to see is also an ageing world. This shows you the number of older people that are aged 90 plus living in the UK today. And you can see there's significant gender differences, but nearly 500,000 people are aged 90 or over, which presents some interesting challenges for health and social care, which is not the subject of this talk, but is something to think about when we're thinking about the challenge of population change. And another interesting feature is that we're actually seeing a rise of the very old. So when the Queen first came to the throne in the 1950s, she used to send a birthday card to everyone when they reached their 100th birthday. And she could do that because not very many people were having their 100th birthday, less than one per day. But now it's virtually impossible. And you can see that today there are over 12,500 people who are aged over 100. I think it's also important to note the shape of the line, the red line, particularly the total numbers of people aged over 100. If we look at the shape of that, that's starting to look a little bit like an exponential curve. And I'll come back to that in a moment. Of course, it's not just the UK which is ageing. And here I just present some data from the United Nations as the oldest old as a percent of the older population in different countries in the world. And you can see that in all the countries represented here, the proportion of the oldest old is increasing. So are there limits to how old we might become? Well, this graph is from some work by Professor Jim Vopel, who's the director of the Max Planck Institute for Demographic Research in Germany. And he's an expert on mortality. And what he's done in this graph is he's plotted the best performing country in the world across time, bearing in mind that for many parts of the world, if we go back as far as 1840, there isn't really very good data outside of Europe. And what he's plotted is the years of remaining life expectancy at age 65. So you've already had to survive to 65, so we're focusing in on older age mortality. And what you can see is the best performing country at the start was Norway, and then we get replaced by Switzerland, and today it's Japan. But I think the most amazing thing about this graph, again, is its shape. The curve looks exponential. So today, in 2010, if you reach age 65 and you're living in the UK, you can expect to live at least another 20 years and possibly beyond that. Looking into the future, for all of you who are born more recently, this table shows you, for different birth cohorts living in different countries in Europe, the age at which at least 50% of the birth cohort will still be alive. So that's the age at which you've got a 50% chance of reaching. So if you were born in 2007, you have a 50% chance of reaching age 103. I think that's quite amazing. So we live in a healthier world, we live in an older world, but we also live in a world with smaller families. And of course, it's not just improvements in mortality that we need to focus on, it's also changes in fertility. And this graph shows you trends in the total fertility rate, again, across the last 60 years. And you can see that in the 1950s, for all of the countries represented here, a woman on average would expect to have at least 5 children. And what we've seen over the last 50 years is a dramatic change in the childbearing patterns of people living in most parts of the world. I think the decline here is most marked in the Republic of Korea. But in all countries in the developing world, including India and Brazil and Egypt, there have been marked declines. However, you can also see from the graph that the only country where there's a stable line is Uganda. And in Kenya, you can see there was a decline in fertility through to the 1990s, but then there's again has been stabilisation. And today, fertility rates really only remain high in sub-Saharan Africa and parts of the Middle East. But in the Middle East, fertility is also falling quite rapidly. I've just picked out China here, because I think China is a very interesting case. As we saw earlier, over 1 billion people live in China, and China currently is the most populous country in the globe. But fertility in China has been transformed from an average of around 6 children per woman in the 1960s to under 2 children per woman from the 1990s onwards. In part, this is a result of government policies. I'm sure you've all heard of the one-child policy. But in fact, fertility in China was falling before the government introduced the one-child policy. But it does, however, mean that China is going to face a very interesting demographic future. And China's population growth has already slowed dramatically. And from about 5 years hence, the population of China is predicted to start to shrink, which may be one of the reasons why the Chinese government announced the reversal of the one-child policy just this week. The 10 places with the lowest fertility worldwide are quite an interesting mix, and I think maybe some of this might be a surprise to some of you. The lowest fertility in the world is in Hong Kong and in Macau, but then there's an interesting mix of Eastern European and Asian countries. So there is low fertility in Bosnia, in Poland, Romania, as well as in Singapore, Japan, and China. What's happening closer to home? Well, this graph shows you the total births in England and Wales over the last 60 years. And you can see very clearly the baby boom of the 1960s, followed by the baby slump of the 1970s, an echo in the 1990s, where the women who were born in the 1960s were giving birth, and then again a baby bust. If I add on what's been happening in the last 10 years, you can see that we're currently in a period of rising birth rates, which lies behind today's baby boom. And each year we expect the birth rate to have slowed down, but so far there are no signs of it doing so. So just to illustrate the changes over the last 50 years, I want to show you a graph from Hans Rosling. This is taken from the Gapminder website. And on the vertical axis we have life expectancy, and on the horizontal axis we have children per woman. So you can see there were two worlds in 1950. A world with high life expectancy and low fertility, and another world with high fertility and low life expectancy. But gradually over time we see changes. So the big red blob that's just gone up and down, that's China. But as we move through time, the countries are moving upwards. So fertility is falling and life expectancy is rising. Now we're starting to see the dark blue blobs fall down. Those are the countries of sub-Saharan Africa, and that's the impact of HIV/AIDS on life expectancy. Life expectancy is now starting to recover a little bit with the rollout of antiretroviral treatments and people living with HIV. But today you can see that we really live in one demographic world of high life expectancy and low fertility, with the only exception to this being sub-Saharan Africa. We also live in an increasingly urbanised world. And today, just over half the world's population live in cities. There's still big diversity in this. So Africa has just around 40% living in cities, whereas Latin America has nearly twice as much, with 80% living in cities. The largest cities in the world are concentrated now in Asia. So you can see that the Tokyo metropolitan area is the largest city in the world with 37 million people. That is a bigger population than many European countries. Behind that is Delhi and then Sao Paulo. And just pushing at the edge of that is Shanghai. Shanghai and Sao Paulo are really competing for third place. But I imagine that in another 5 years we'll see a transformation of the league table, with probably two of the top three cities in the world being in China, as the Chinese cities expand dramatically. Urbanisation is also linked to the risk of natural hazards. And I think it's very interesting to note where the concentration of the largest cities are. And they tend to be along the coastal regions. And we've seen over the last few months the risks of large concentrations of people in low-lying coastal regions. And I think you're going to come back to the relationship between urbanisation and natural hazards in some of your other lectures in this course. So where next? Well, according to the United Nations population forecasts, we'll hit the next billion in 2025. So it would have taken us 14 years. And then the pace of change continues to slow down. We hit the 9th billion in 2043, the 10th billion in 2083, and then we stabilise out at pretty much around this level. But there are big question marks. And this graph shows you a number of different variants. So the central variant, or the medium variant, is the one that is behind the numbers that I just presented to you. But what I want to just pull out for you is the difference that fertility makes. So the difference between the high variant, the medium variant, and the low variant is just plus or minus half a birth per woman. And if we assume the high variant in fertility, then actually the world's population by the end of this century will be around 27 million. Whereas if we assume the low variant, we actually see population decrease, and we'll finish this century with a lower population than we started. To slow population growth, developing countries' fertility decline must be rapid, and we know that that is possible. So this graph just picks out time trends over a long period of time of fertility in the United States and Bangladesh. So both the US and Bangladesh had fertility of around 7 children per woman in 1800. And they've both ended up in 2007 with, again, quite similar fertility. But you can see that in Bangladesh it was stable all the way through, really until 1980. And then what happened in 1980 was that the government decided to roll out family planning programs. So there was a big publicity campaign, but they also made contraception freely available. There was no coercion, it was just making informed choices available to women and couples. And actually, once the population is open to the idea of controlling their fertility and you make the means of control available, then fertility can decline very rapidly indeed. So the key challenge, or the key factor behind whether we'll end up at the end of this century with a world population of 27 billion or 6 billion really rests in how fast fertility in Africa falls. Because as we've seen from the previous slides, in most parts of the world now, fertility is already fairly low. And it's actually that band of countries in sub-Saharan Africa which has high fertility, which is going to drive population growth over the next 50 years. I want to just pause for a moment to think about the relationship between development and fertility. And at the population conference in 1974, the term development is the best contraception was coined. And that primarily came from looking at the relationship between the Human Development Index and total fertility, which you can see here on the blue line. In 1975, there was a very strong linear relationship between the two. And a colleague has replotted this data for 2005. And I think it's very interesting to see that at low levels of development, that linear relationship still exists. So one of the keys for thinking about fertility decline in Africa will be thinking about raising human development. But at the high ends of development, you can actually see that development is associated with higher levels of fertility. And that's interesting for countries such as the UK or Germany or the Scandinavian countries where we have fertility below 2.1, which is the net reproductive rate, so that's the number of children you have to reproduce yourself. And many European countries are becoming concerned about low fertility. It shows that actually, if you want fertility to rise, you need really high levels of development. And there, we're thinking about things such as gender equity. So if you want to have a bounce back from low fertility, then you actually need to start thinking about how you empower couples to take equal roles in the child rearing of their families. So that's just another thing for you to be thinking about. Okay, so this course is all about global challenges. I've really focused on population, but there's been a lot written about the relationship between population and resources. This has been debated since Malthus, over 2 centuries ago. So Malthus posited that populations, food grows arithmetically and populations grow exponentially unless unchecked, and so eventually over time there'll be a conflict between population growth and resources. Malthus happened to write just before the Industrial Revolution, and so actually his ideas ran into the sand, so to speak, because in fact population growth started to fall because fertility started to fall as a result of the Industrial Revolution. But in the 1960s, his ideas then regained currency. And you can see the reason why for that if you think back to our very first picture, where we see the dramatic rise in world population. And in 1968, a book called The Population Bomb by Ehrlich and Ehrlich warned of impending disaster if the population was not brought under control. However, there are countervailing views to the neo-Malthusians, and those are probably most best represented by Julian Simon, who argues that in fact people are the ultimate resource of the world, and material conditions of life will continue to get better for most people in most countries most of the time. And as we have a growing population, so too do we have more ideas, more innovation, and we're able to cope with that. And actually, if we look back over the last 30 years since the Population Bomb was written, we see that most people in the world have enjoyed improving life, living conditions, despite the fact that the population has doubled. But there is no doubt, I don't want to to say that we shouldn't care about population growth, because certainly we have seen changes in the availability of land use, and we have seen changes in the resources that are available to us. But just as we think we're consuming those resources, then we find new alternatives or new stocks of resources. It is thought, however, that there may be a limit to how much food we can produce. And I think many of the experts, and you'll have lectures in this course from other people who work in these areas, think that possibly there is a limit of around 9, perhaps 9.5, maybe 10 billion to the limit of people that we can feed. And between now and 2030, the United Nations estimates that food demand is set to increase by 40%, and demand for energy and water will increase by 30%. So this leads us again to these Malthusian questions of whether we can feed the rising population. I do think it is important to note, though, there are big differentials within the globe in terms of how much food we consume and how much energy we use. So in the United States, carbon emissions per person are 20 times those of India. Just thinking about those differences in food, I just want to give you very quickly a quick flick through an average family's food consumption in different parts of the world. So this is an average family in America. You can see what they're eating. Some of it looks quite healthy, some of it looks not so healthy, but they spend on average about $500 a week on food. A different family in the US from North Carolina are spending just under $350 a week on food. There the food looks slightly different, not quite so much fresh fruit and vegetables. Moving to Sicily, $260. Down to Mexico, $189. And again, you can see that the composition of that average diet is also changing. Poland, 150. Cairo, 68. And now you can also see that the number of people that that food is going to feed is also changing, the number of people in the background of this family. Peru, $31. Bhutan, just $5 a week. And finally, if we move to Chad in Africa, under $2 a week, and a very different composition of diet to that first family that we saw. So I think it's very important that we don't just focus on the numbers of people, but we also focus on the distribution of resources and the composition of their diets and their weekly shopping baskets. Of our 7 billion people today, it's estimated that about 1 billion of us overeat. Many of those are concentrated in the more developed countries, but not only. It's also estimated about 1 billion are hungry and another 1 billion are malnourished. The United Nations suggests that about half of all food produced for human consumption goes to waste. In developed countries, 50% of our food is discarded after purchase. If you think about what you have in your fridge, back in your flat or house, and how much you throw away each week. And that's also thinking about how much food is discarded in the supermarkets themselves. In developing countries, 50% is wasted prior to purchase. And the main causes of that are pest infestation, poor storage and poor access to markets. So food actually can go to waste in the fields or en route to the markets. So if we think about that in the round, we know we already grow enough food to nourish at least 9 billion people. So I just leave you with the thought that uneven distribution across the globe may be a more potent cause of malnutrition and hardship than any ceiling to what the planet can supply. So as a demographer, I'm not saying demography is not important, but it's how it interacts with our economic and social systems that is important. Thank you.